Welcome to lesson 47. We're going to look at our last method for systems of equations, elimination. And when you eliminate something, we turn it to zero, turn it to nothing. So for this method, we're actually going to express equations in standard form. And we're going to identify if either pair of the coefficients create opposites. So we're looking for zero pairs. I'm just going to make this super easy. That's what we want. We want zero pairs. Now, if there are no zero pairs, then we're going to create them using common multiples. We're going to do some multiplying. So I'll let you see what that looks like. Then once we do that, we're going to substitute for a value. And that's the goal. We want to either get rid of the x's and leave the y's, or we want to get rid of the y's and get to x. And once we find x or y, we're going to substitute in to figure out what the other one is and find the ordered pair. All right, so let's have them written in standard form so we can stack them up. These are already written in standard form. So we have x minus y equals -2, and 2x plus y is equal to 8. So luckily they're in standard form, and I can stack them on top of each other. And that's what I want. I want the x's on top of each other, I want the y's, and then I want the constant on the other side on top of each other. And what we're looking for is an ordered pair. So when we add them together, do they make 0? This won't, but this will. And that's what we want. We love this because these will cancel out. That's a lovely 0 pair. And I end up with, when we add, 3x is equal to 6. And that's awesome because now I can solve this part and I get x is equal to 2. And I want that part. So I have one part of my solution already, so I know I'm going to have a solution. Now I can substitute x for either one of these. I'm going to do x minus y equals -2. So 2 minus y equals -2. Negative y is equal to -4, and I just want y equal, so I'm going to divide both sides by -1. Y is equal to 4, and there we have it, my friends. We have our solution. X is 2 and y is 4. So these two equations are equal to each other when x is 2 and y is 4 at that exact point. So hit pause and jot this down into your notes. So let's go into the next one. Luckily, these are already written in standard form, so it makes it easier to stack. And again, what we're looking for is when we add, do we have 0 pairs? Not here. Not here. No. So this is the problem, and I don't even care about these. I'm looking for my x's and y's. I need to create a 0 pair somewhere. Since we don't have one, we're going to have to do some multiplying. So what could I multiply? And I go simple first. Can I multiply one equation by a number and get a 0 pair? Yeah. I'm looking right here. What if I multiplied this by 4? If I multiplied this by 4 and made -8, then I can get rid of it. So, haha, we have a solution. So I'm going to take this and I'm going to multiply it by 4. So let's rewrite this equation now. I'm going to distribute by 4 and I get 8x minus 8y is equal to -40. There we go. I've just distributed. And now I'm going to take the other equation. I don't have to do anything to it. 3x plus 8y is equal to 7. Got what I wanted. I wanted to have a 0 pair. Here it is. So I'm going to eliminate this. And I'm just going to add. So now I have 11x is equal to -33. Let's divide by 11. And x is equal to -3. And again, that's what I want. I want to make sure I have what an x is or a y is equal to, and that's the point of eliminating. So now that I have x is equal to 3, I'm going to go back up and just substitute. So 3x plus 8y is equal to 7. Substitute for x. Negative 9 plus 8y equals 7. Eight y is equal to 16. Kind of like that red right now. And y is equal to 2. So there's my solution. These two lines will be equal exactly at the point negative 3, 2. So let's make sure we put that solution down clearly. Solution negative 3, 2. And I know this sounds really silly that I'm writing it down on a line, making it clear, but I want to make sure that we understand that this is an ordered pair. This is a specific point in the situation where both things are true. So please make sure you write your solution down as an ordered pair. All right, hit pause and jot this down into your notes. So we're going to do one more altogether before you do a try, and I want to show you a situation where it's a little bit more complex and we want some decisions to happen. All right, so first things first, when you're adding, you can see again, I got no zero pairs. I need to, is there any way I can multiply one equation to make the other? No, there's no way I can multiply this 4 and get a 3. There's no way right now that I can multiply by a whole number anyway, this negative 13 to get a zero pair with 9. So I'm going to have to find the least common multiple of a set of numbers. And I'm going to choose these right here. So I'm going to put this into my notes. Find the least common multiple of 3 and 4. If you don't remember how to do that, when you were younger, you did this all the time. You just skip counted. Remember this? Where you just skip counted by numbers. You did the same thing with the other one. And you found out what their common multiple was. So that's what we're doing here. So if you find that there isn't one way to multiply, then you're going to have to multiply both equations. All right, so let's figure out the top one. How do I get that negative 3 to become a 12? I'm going to multiply this one by 4. And how do I get that 4 to become a 12? I'm going to multiply this by 3. Okay, and notice again, I do want one to be negative and one to be positive. So let's distribute, and I'll start with the top one. 4 times negative 3 is negative 12x plus 36y is equal to negative 12. And the second one is 12x minus 39y is equal to 15. Let's add these up. We could already see here's our zero pair, which is what we wanted. And 36 minus, when we plus negative 39, I'm going to end up with a negative 3y. And negative 12 plus 15, I'm going to end up with a positive 3. Okay, so divide by negative 3, y is equal to negative 1. So awesome sauce, we figured out what the y is equal to. So I'm just going to take one of the equations. I don't want the one with the 13. Not because it's scary, but just because I just want to reduce opportunities for error. That's all I'm doing here. And let's substitute for y when y equals negative 1. Okay, so I get negative 3x minus 9 equals negative 3. Negative 3x is equal to positive 6. And x is equal to negative 2. So here we go. We have both parts for our solution. We have when y equals negative 1 and when x equals negative 2. So let's express our solution as negative 2 -1. All right, hit pause and jot this down into your notes. Okay, we've had a lot of practice with the elimination method, so let's do one more on your own, this time for guided practice. Hit pause and work on the practice problem on your own. Great. Now let's get ready to reveal the solution to this problem. And the answer is -2, -3. Go back into your notes and check to see if you had the same answer. If you had the same answer, great. Keep going to the checkpoint. If you didn't, try and see where the answer was different, if you had a different decision or a different choice. And if you're still not sure, you'll find a bonus video in the description where I go over this method. That's it for today, Math Marbles. I'll see you in the next one. Be well.